For the last couple of weeks, I've been getting this creative itch that I just really needed to scratch. I wanted to do something with 3D printing, but I really wasn't sure what to make. So I just started to rack my brain for ideas on what to print. Well, for me, it really just didn't take long for me to figure out what I wanted to do. I really wanted to make a catapult. There's nothing particularly special to me about a catapult. I just thought it'd be really cool to make something that can shoot stuff. The catapults that I showed in the opening B-roll were either not historically accurate or just far too complicated for my first project. I wanted to make something that was currently not available, historically accurate, and easy to assemble. So, because I want it to be easily assembled, I don't want it to require screws or glue for the construction. My hope is that with this project, I'll become more familiar with 3D printing and design. And when it comes time to 3D print it, I like to try different plastics and print orientations just to test what is the most robust and durable. The first thing I did when it came to this project was make sure it's actually possible to 3D print models from SOLIDWORKS. I'm aware that I'm going to need a slicing program of some sorts, but I'm just leaving that up for later me to figure out and solve. I chose SOLIDWORKS because I already had it and I was pretty familiar with it, and it's a software that's still used in industry, so I figured it wouldn't hurt to be more familiar with it. Here you can see me roughing out some designs that I plan to make on SOLIDWORKS just on my OneNote app. My design is based off of this catapult that I saw online. I chose this one because it looks simple, and as I said earlier, I want this to be easy to assemble, but you will need some string for this. Though I figure this is still much simpler than the other designs that are available online, so I think I'll just allow myself to require one piece of string. So right after drawing those rough sketches, I started whipping up some models in SOLIDWORKS. These parts are going to be simple at first, and that's on purpose. I just want to make sure that everything will fit together nicely. That's a lot easier when you're working with simple models. Once everything fits together nicely, though, I'll start working on the more complex details, such as how everything's actually going to physically fit together. I'll probably use like friction fits or some woodworking kind of jointery, but for now, I'm just making it real simple and getting everything together. So that's where I just left it for the day. The bow frame was being a real pain in the butt, and it wasn't attaching properly to the rest of the frame. I figured that this was pretty good progress for just one day, and I addressed it the next. The next day, I remodeled the bow. I gave it that extruded rectangular bit so that there would be a flat surface to mate against the frame. Next, I put holes through the launcher and the frame for the axle to go. Then I made drawings for all the parts. This will help with the documentation for what I expect to be just one version of many for this catapult. When I started fitting everything together, I noticed that the bottom of the launcher pokes out beneath the frame, which would prevent full range of motion if I were to actuate it on a flat surface. So I'm going to have to add some wheels later. Okay, so on day three, all right, I'm not going to go on talking about all these different videos I watched. I watched like three or four, and honestly, they're not that great. But this last one right here is absolute gold. It's got a lot of practical knowledge, and there's actual real stress testing on these things that's very useful for something like what I'm doing. So we're just going to cut this out or save you the time, and it's just going to be a better video. Trust me, okay? You just got to trust me. Now here is the best video I watched. I watched about like 2 hours worth of videos. This one does strength testing on 3 different types of joints. I'll still leave the links to the other videos in the description, but this one was by far the best. So please just watch and enjoy this amazing video.
27.5 pounds. 30 pounds. 30 pounds. How on earth? So correction, the last one was 52.5. I forgot to remove a plate, so this one is 55.
This member fractures right where the joint starts. You can see that the fractured area is much smaller than the overall cross-sectional area of the member. This happens because in order to have both parts of the member overlap in that way, you need to reduce the area of both of the members. So I will consider this to be a joint failure. This member fractures right in the middle of the joint. I think once again this is due to a reduction in the area of the fracture plane. Therefore, I'd consider this a joint failure. As you can see, the final joint failed at 55 pounds, which is nearly double the weight of the next best joint. The fracture plane did not occur within the joint itself, so I'd consider this to be a material failure. But perhaps with a stronger info pattern, you would see the joint itself fail, but that is not the case. I think though that ultimately I'm gonna have to go with this tapered dovetail design. Although it has a lower maximum capacity, it's a lot better for the size that I'm working with. In order for this jointery that's used for woodworking to be usable and done only with 3D printing, I think I'm gonna have to have like a 1 inch by 1 inch sizing for my members, which I think would just be too big for my application. My worry is that if I were to have to print out these little wedges, that when you go to try and mush them in together, that they would just break because they're too weak. Just really small cross sectional area, and then trying to force them in, I think the forces required would just be too high. And that's why ultimately I will be going with the tapered dovetail. And so this is the end of the video. I really appreciate your time and attention. This is just the first of 3 videos. In the next video, I'll be doing all the jointery work. I'll add wheels and a hook on the launcher for the string to go. And on the last video, I'll cover the printing process and the fatigue testing for the different filaments. Thank you so much, and I'll catch you in the next one. Goodbye.